Welcome to DA classes. Today we're going to learn about common forces in mechanics. Understanding forces is crucial for solving physics problems because forces cause objects to accelerate according to Newton's second law. Before we dive into specific forces, let's remember that a force is a push or pull on an object that can cause that object to accelerate. Newton's second law states that the net force on an object equals its mass times its acceleration, F equals ma. Let's start with one of the most familiar forces, weight. Weight is the force of gravity acting on an object. The formula for weight is W equals mg, where m is the mass in kilograms and g is the acceleration due to gravity, which is approximately 9.8 meters per second squared near Earth's surface. The next important force is the normal force. The normal force is a contact force that acts perpendicular to the surface of contact. When an object rests on a surface, the normal force balances the weight of the object, preventing it from falling through the surface. The formula for the normal force on a flat surface is N equals mg cosine theta, where theta is the angle of the surface relative to the horizontal. For a flat horizontal surface, cosine of 0 degrees equals 1, so N simply equals mg. Let's see how the normal force changes on an inclined surface. When an object rests on an inclined surface, the normal force is perpendicular to the surface, not vertical. On an inclined plane with angle theta, the normal force is N equals mg cosine theta. Notice how the normal force is smaller on the inclined surface than on a flat surface, because it only needs to balance the component of weight perpendicular to the surface. Now, let's move on to our next force, friction. Friction is a force that opposes motion and occurs when two surfaces are in contact. There are two types of friction we'll discuss, static friction and kinetic friction. Let's first look at static friction. Static friction acts when an object is at rest relative to the surface. If you apply a small force to an object, but it doesn't move, that's because static friction is resisting the force. The formula for the maximum static friction is F sub S max equals mu sub S times N, where mu sub S is the coefficient of static friction, and N is the normal force. It's important to remember that the actual static friction force matches the applied force until it reaches its maximum value. After that, the object starts to move. Now, let's talk about kinetic friction. Kinetic friction acts when an object is moving relative to the surface. It's typically less than the maximum static friction. The formula for kinetic friction is F sub k equals mu sub k times N, where mu sub k is the coefficient of kinetic friction, and N is the normal force. The coefficient of kinetic friction is usually less than the coefficient of static friction for the same surfaces, which is why it's easier to keep an object moving than to start it moving. What factors affect the amount of friction between two surfaces? The coefficient of friction depends on the nature of the two surfaces in contact. Rough surfaces generally have higher coefficients than smooth ones. Interestingly, the friction force doesn't depend on the apparent area of contact. A larger box with the same weight has the same friction as a smaller box. However, friction does depend on the normal force, which is affected by weight and any other forces pushing the surfaces together. Let's work through an example problem involving friction. A 5-kilogram box sits on a horizontal surface with a coefficient of static friction, mu sub s equal to 0.3, and a coefficient of kinetic friction, mu sub k, equal to 0.2. If a horizontal force of 10 newtons is applied to the box, will it move? If so, what will its acceleration be? Step 1. Find the normal force. Since the surface is horizontal, the normal force equals the weight. N equals mg equals 5 kilograms times 9.8 meters per second squared, which equals 49 newtons. Step 2. Find the maximum static friction force. F sub S max equals mu sub S times N equals 0.3 times 49 newtons, which equals 14.7 newtons. Step 3. Compare the applied force to the maximum static friction. Since the applied force of 10 newtons is less than the maximum static friction of 14.7 newtons, the box will not move. If the applied force were greater than 14.7 newtons, the box would start moving, and we'd use kinetic friction to find the acceleration. For example, if the applied force were 20 newtons, the kinetic friction would be mu sub k times N, which is 0.2 times 49, giving us 9.8 newtons. The net force would be 20 minus 9.8, which is 10.2 newtons, and the acceleration would be 10.2 divided by 5, giving us 2.04 meters per second squared. Let's move on to another common force, tension. Tension is a pulling force exerted by a rope, string, cable, or similar object on another object. Tension always acts along the rope or string. For an ideal string, which is massless and inextensible, the tension is the same throughout the string. For real strings with mass, the tension can vary along the string. Let's look at a simple system where a box is being pulled by a rope. The last force we'll cover is the spring force. The spring force is a restoring force that acts to return a spring to its equilibrium position. According to Hooke's law, the spring force is proportional to the displacement of the spring from its equilibrium position. F spring equals negative k times x, where k is the spring constant, and x is the displacement. The negative sign indicates that the force is in the opposite direction of the displacement. If you stretch a spring, it pulls back, and if you compress it, it pushes out. Let's summarize the common forces in mechanics we've learned about. 1. Weight force, W equals mg, the force of gravity acting on an object. 2. Normal force, N equals mg cosine theta, perpendicular to the surface of contact. 3. Friction force, including static friction, F sub S max equals mu sub S times N, and kinetic friction, F sub K equals mu sub K times N4. Tension force, a pulling force exerted by a rope or string, constant throughout an ideal string. 5. Spring force, F spring equals negative K times X, a restoring force proportional to displacement. Thank you for watching. If you liked the video, please like it and subscribe to the DA Classes channel for more educational content. See you next time.